For the next one, we have graphs, and then we have to look at the rate of change of them. So what can you tell me about the rate of change of the first graph, which is a line?
It's linear, it's constant.
It's a constant,
constant.
right? So it's going up by 2 over by 10, right? So 2 over 10, 2 over 10, 2 over 10, right? So the rate of change is constant, and all points are in a straight line. How about the next one?
It's not constant.
It is not constant. What's happening at the beginning?
At the beginning, it's increasing slowly, then it's increasing rapidly.
That's right. So we have a slow increase and then a rapid increase, right? So we're gonna say that the ROC is increasing. You see how we said right here the ROC is constant, the rate of change is constant. In this case, the rate of change is increasing every 10 kilometers per hour. Interval. And points are not on a straight line. Right? Right? If it would be a straight line, it would be like this, right? This is not a straight line, the red is not a straight line, it's a curve. Okay? All right. So, the table below shows the change in height of a tomato plant from germination until the tomato ripens. Okay? So the height of the plant from the minute that they germinated until it just becomes ripe. The first question is asking you determine when the rate of change in the height is 0. So determine when the rate of change in the height is 0. So I'm looking at when my slope is 0, correct?
Yeah.
Now, you see that this is all going up by 2,
Yeah.
right? If you look at this, it's all going up by 2. Good. So let's look at the rate of change. We have to calculate the rate of change. So I have to do 5 minus 0 over 2. Make sense? So that's 5 over 2, which is 2.5. Okay, so I'm finding the rate of change. Y2 minus Y1 over X2 minus X1. I'm not going to write the whole thing. Are you guys okay with that?
Yep.
Okay, 10 minus 5, so that's 5
4.
over 2, so that's 2.5. 20 minus 10
10.
is 10 over 2, that's 5. 40 minus 20, that's 20
20.
over 2, so that's 10. Remember that the rate of change here is in centimeter per week. Okay, so that means in this case it's growing up 2.5 centimeter for the first week, 2.5 centimeters after that, 5 centimeters in the next week, and then 10 centimeters in the week after that. Okay, so you see that right here, we have kind of a fast growing plant, right? Then I have 58 minus 40, so that's 18 over 2. So So that is 9. Then I have 75 minus 58. So that is 17 over 2, which is 8.5. Then I have 86 minus 75, so that's 11 over 2, which is 5.5. 90 minus 86, so that's 4 over 2, which is 2. And then 90 minus 90 is 0 over 2, which is 0. Okay? So at first we saw that a kind of constant increase, right? Then it started increasing rapidly. Then it started to, it's still increasing, but it's increasing less slowly, right? So 9 centimeter per week, 8.5 centimeter per week, 5.5 centimeter per week, and then until it reaches 2 and then 0 centimeter per week. So the question is asking, determine when the rate of change in the height is 0. So when is the rate of change in the height 0? Between what week?
18.
Between week 16 and 18, right? So I'm comparing this and this, right?
Yeah.
So between week 16 and 18, that's when I have no change in the height of the plant. When is your change constant? So it's changing, but constantly changing.
16 to 18 week is 7 to 8 week.
It's 12 to 14.
12 to 14 week.
Why?
Constant?
Constant.
Oh, 0 to 4?
0 to 4.
Oh, yeah.
Right? Because between 0 and 4 week, I have the same rate of change, which is 2.5 centimeter per week. Okay? So that would be, for my constant, it would be between week 0 and when is it changing?
6.
From week 4 to 14.
So 4 to 16. Okay? So between week 4 and 16, it's changing. You see that the rate of change is not constant, right? It's changing right here. When is the rate of change in height is the greatest?
There's 9. Is it
The greatest.
The greatest.
10.
10.
It's 9. The height is 9.
No. You have 10. You have this.
Yeah.
Okay. Sorry.
So that's between week 6 and 8.
16.
Right? Between week 6 and 8, I got 40 minus 20 over 2, so that's 10. Okay? If you look right here, between week 6 and 8, so you see that my line is the steepest line. If you look, it's the steepest line between, like this is steep, right? But it's a little bit less steep. This is a little bit more steeper than the other one, okay? So it's not only that it has the highest slope, and then you can see it on the graph as the steepest line. I shouldn't say first difference, I should say ROC is the largest. The difference between first difference, eyes on the board for a second. The difference between first difference and ROC, or the rate of change, is that for the first difference, you're only subtracting the y's. Remember from last semester, I mean, when we did the first difference, right?
Yeah.
We did y2 minus y1, y2 minus y1, y2 minus y1, right?
Right.
The difference between that and that is that the first difference, you only do the y's. With a slope, or the rate of change, you have to divide by the x.
Because
Okay.
it's exponential separation. We do it. Exponential.
That's a different thing that you're talking about. Okay? Anytime you're finding the rate of change, you do y2 minus y1 over x2 minus x1. If it's asking you for the first difference, you only have to do y2 minus y1. Describe the growth of the plant. So I'm gonna type this because writing this is on this board is not very fun. Okay, so it grows at a constant rate at first. From 0 to 4 weeks, then grows, then a growth rate increase for the next 4 weeks. Then growth rate decreases as the plant reaches maturity. After week 16, the plant stops growing. Right? It was increasing slope, and then the slope started to decrease as the plant started to mature. Now, tell me that I have spelling mistakes. Now, if you look at the graph, what do you see has happened when your rate of change is 0? When the rate of change is 0, what do you see?
It's constant.
It's what's happening to the graph.
It's decreasing.
I
again.
start
No.
decreasing. No.
It's
constant.
a horizontal line.
Oh.
It's a line that's horizontal, right? So your rate of change is 0, right? When your graph is horizontal. There's no change in the y. Do you see that?
Yeah.
Okay? So let's look at this. When the rate of change is 0, then your first difference is also going to be 0, right? Because here, if I go back here and just do the first difference, which is 90 minus 90, right? That's 0. Also going to be 0. And then you're going to have a horizontal line. Okay, so you're gonna see a horizontal line, then your slope is 0, same as your first difference. Okay, remember rate of change means slope. Now, if your first rate if the rate of change is constant, then your first difference is also constant. And you're going to see a straight line, right, where your first difference is constant. if your rate of change is changing, then the first difference is gonna be changing as well. And then you're gonna see a curve graph. Okay? So I don't know if you remember this. Do you remember that when we did the first difference and second difference? And if your first difference is constant, then you
Right.
have a linear function.
Yeah.
And if your second difference is constant, then you have a quadratic function.
Yeah.
So in this case, if your first difference is constant, you have a linear. If the first difference is not constant, we haven't moved to the second difference yet, right? If your first difference is not constant or your slope is not constant, then you will have a curvy line.
Mhm.
Okay? Are you guys okay with this? All right.